Problem number 88. The product of non-zero eigenvalue of the matrices. We have our previous example. Now we will solve this using partition technique. We have four options: 4, 2, 6, 8. Now this is our matrix. For our clear understanding, we will take vector as x1, x2, x3, x4, x5. Now we can clearly see these elements are, or these entries are easier to separate, as x1 and x5 are easier to separate. We can see x1 and x5 are similar, so we will write x1 and x5 in a equation, and we can see x2, x3 and x4 are looking similar, so we will write x2, x3, x4 in our equation, and we will eliminate zeros everywhere, and there is no point of writing like x1 0 x1 plus 0 x2 and 0 and likewise, so we will ignore the zeros. Now we separate. We will separate similar looking. We will separate x1 and x5. We can write x1 plus x5 is equal to 0. We can write from last row x1 plus x5 is equal to 0. As our each entries are 1, so our coefficient 1. Now we have to write row 1, row 2 and row 3. We can write x2 plus x3 plus x4, each has coefficient 1 which is equal to 0. We will write as equation x2 plus x3 plus x4, and same here for row 3, x2 plus x3 plus x4 is equal to 0. We have written here in our equation form. This is our equation form. We have simplified our 1 1 1 1 1 1 1 1 1. This is our x1, x2, x3. This is our matrix form. This is our matrix form. So now it is clear what is matrix form and equation form. Now we solve our problem. Now we know what is partition technique, and this technique is useful in bigger problems which looks similar. Now for this matrix, we have 3 rows. We have 3 rows, sum as 3. Each row has sum as 3. 3 rows are identical, means 2 eigenvalues will be 0. Now sum of each element in a row is 3. Therefore one eigenvalue is equal to 3. Now our lambda for this matrix will become, eigenvalue will be 0, 0 and 3. Now we separate our x1 and x5. x1 plus x5 is equal to 0, and x1 plus x5 is equal to 0. We can write this in matrix form 1 1 1 1, and this will be our x1 x2. This is our equation form and this is our matrix form. Equation form, and this is our matrix form. We have two rows identical, means one eigenvalue is 0, and sum of each row is 2, so one of the eigenvalue is 2. Therefore, and sum of each element in a row is equal to 2. Therefore, one of the eigenvalue is 2. Therefore, lambda will be 0 and 2. Now final product of non-zero eigenvalue is 2 into, we have one non-zero and second non-zero, 2 into 3, which is 6. So this problem becomes more easy from our partition technique.